so my name is Connor, and I'd like to talk to you about a system called Marathon, as you can tell by the title slide. Downloading. There's supposed to be a picture here. It's coming from the internet. It's on its way. But I work for a small startup called Mesosphere. We're based here in San Francisco. We're about 30 people in 2 offices, and we do tools and frameworks on top of Apache Mesos, in addition to contributing to Mesos core. Marathon's one of those tools. So here's where I'm going. First of all, we're going to talk about what Marathon is. Then we'll take a brief detour. We'll call it a lightning detour into Mesos internals, just so you can understand the model we're working with. And then we'll dive back into some more features that you can, some more things that you can do with Marathon. We've got a very, very pretty logo. So Marathon is first and foremost a Scala application. It's a Scala application to run your Scala or other language implemented applications. It can run any Linux binary, and it runs things on a cluster. It's open source, Apache 2 licensed. It's up on GitHub. And it's a framework for Apache Mesos. Could I just have a quick show of hands? Who's heard of Mesos? OK, it's about half. Who's used it? Less, OK. I'll talk more about what this means in a little bit. All right, so the goals of Marathon first is to be a self-serve interface to your cluster. The idea is that any one of your developers or ops people can go to Marathon, supply it with a description of an application, along with how many instances you want to run, and Marathon just makes that true through magic. In this way, it behaves kind of like an init or an upstart system for long-running services. And this is kind of another way to say that. But it provides a private pass, so you can run it on AWS or GCE or on your own machines. OK. Be having trouble with the internet here. Let me just try to reload this image. Here it comes. OK. We're dependent on the internet here. But this is a view of the UI. Here we go. So basically, you have this form. This is how easy it is to launch an application in your cluster. You fill in the simple information about your application. Oh, it stopped. OK, let's skip ahead. OK. All right, so these are the things that you can do with Marathon. There's a nice UI. It didn't work, but you can start, stop, and update the definition of your running applications. You can see what tasks are running. You can kill an individual task, or you can do all of those with both the REST API and the web interface. We also have a nice REST interface. So first example here is you just do a simple post to launch an application. You can do a get to see what applications are running. You can put against the application to update the app. Or you can do a get against the task collection to see what tasks are running. You can also do a delete against a specific task to kill that instance. So let's jump back into Mesos. So maybe just suspend disbelief for a minute here. The idea is that you give Mesos an entire cluster. So Mesos is a top-level Apache project. It's obviously open source, free to use. And what it does is it aggregates the resources in a cluster. So it keeps track of all of the CPUs and RAM and whatever other resources you want to account for inside your cluster. And it keeps track of what is used and what's left over. In addition to doing the resource accounting, it also enforces those resource limits using Linux cgroups. It's pretty robust. It's been in production at some of the largest web scale companies, eBay and Twitter, two of the sponsors. Every tweet you see runs through systems that run on top of Apache Mesos. It also provides somewhat of a SDK for distributed applications. It provides some primitives that you can take advantage of so that you don't have to re-implement them. One of which is distributed state, another is message passing. But it can really accelerate the development of new distributed systems. So at a high level, the motivation for this is that cluster scheduling with heterogeneous jobs is extremely difficult. And so Mesos breaks that into two levels, the first of which is the resource accounting level. So it keeps track of what's available, and it delegates more specific logical decisions to the applications that are running on the framework, or running on the cluster. And the main idea here is that you have a resource offer. So Mesos will take a chunk of resources in the cluster, hand it to a framework, and the framework can decide to either launch tasks or to decline those resources. So an application that sits on top of Mesos is called a framework. There's two parts. One is the scheduler, and that's the part that receives resource offers from the cluster. And the other part is the executor, which is the part that runs tasks. OK. Here's the same idea in picture form. So we have a scheduler that is receiving a stream of resource offers from Mesos. It can decide to launch tasks. Mesos will spin up the executor for that task, and then report back status to the scheduler. And this is all no single point of failure, works on thousands of machines. So the Mesos master can die, the slave can die, the executor can die, your framework can die, and we can survive all of that. So let's just slip Marathon in from the previous picture. So since it does implement the Mesos scheduler API, it's receiving the stream of resource offers from Mesos. At the same time, it provides a REST API for you to define your application. So your application definition is just a blob of JSON. And one of the items could be URIs, which is your application package, a zip or a tar, what have you. And then also the number of instances of each application you want to run. And Marathon it'll compute a queue of tasks that need to be launched on the cluster, and then drains that queue using the resource offer stream. And it also provides an API for introspecting what's running and where it is running. So at a high level, Marathon puts an abstraction above the tasks that are running in the Mesos cluster called an application. And every task is an instance of one of the apps, and Marathon will launch tasks for applications. It receives updates from the system about whether the task is still running or not. So if a machine in your data center just explodes, Marathon will know that that task was lost, and it'll start it somewhere else in the cluster. Just a look at a couple of internal components. So we have an application definition, which is an immutable thing. And we have an app update, which is a diffing type for application. Just so it's a way for us to keep history. So we have the Marathon scheduler, which is also the part that receives resource offers. And then we have a task tracker, just so that we can keep track of what's running and make your state what you want. So here are a few more advanced features of Marathon. It has an event bus so that you can subscribe an external program. You can provide a REST endpoint, and Marathon will push updates into it as events happen. Task comes up, task goes down. As I mentioned, applications are versioned, so you can look at the history of your application definitions. You can post previous timestamp and effectively do a rollback. It's highly available, so it does leader election through Zookeeper. It supports placement constraints. So when you spin up your Mesos slave, so every machine in the cluster has possibly attributes. You can say this machine has fast disk, this machine has like a InfiniBand or whatever. And then those attributes are surfaced in the resource offer. And you can hang off of those for scheduling decisions in your application definition. It also does health checks. So you can set up like an endpoint on your application and a frequency and timeouts and everything like that. It'll keep track of whether the application's healthy or not. If it's not healthy, past a maximum number of failed health checks, then it'll kill it and start it somewhere else. And so the main idea is just to make your operations completely automated. So, upcoming in the next release, which is maybe next week or two, rolling deploys and restarts, namespaced applications. So you can define basically groups of applications. You can have a DAG where you have a product with a front end and a back end, and then applications under those. And you can declare an explicit dependency, say the front end depends on the back end, so that when you issue a scale against the product, it'll scale the back end first and then scale the front end. So health checks on the executor. If you've got 10,000 nodes, you don't want like a one-to-n fan out. And so this is a way for health checks to be executed on every node, and then only the changes in health status are forwarded back to the scheduler. It's a much more scalable way of health checking your applications. Artifact staging is a new feature. This means that if you have URIs, like basically your application package, you can stage them into HDFS, and then you don't have, again, that one-to-n fan out where you're like pulling from your Maven artifact repository from every node. Exponential backoff. This helps when you have a flapping task. So a task that, for some reason, the configuration is just bad. It's never going to become healthy. We back off so that you don't fill up your disk with dead things. Also, first-class Docker support. So this is a feature that's coming into Mesos core, and we're going to support it in Marathon as well. You just supply a blob of JSON that points at a Docker container. You can run a custom command inside the Docker, or you can just do a Docker run. And that's all for free, out of the box. That's it for now. Yeah, so it's up on GitHub. PRs are welcome. It's all in Scala. You all know Scala, so let's be friends. And we're also hiring Scala developers, and Go and C++ if you swing that way. But that's it. Yes?
So how do you compare the Mesos with Yarn?
OK, so the question was how do you compare Mesos with Yarn? And so first of all, they're very similar systems. They're both doing cluster scheduling. Mesos predates Yarn by quite a bit. But basically, Mesos's model is supposed to be more general and abstract than Yarn's. Yarn's tends to be a little bit more Hadoop-centric. But in all, they're very similar projects. Yes?
Are Meses tasks, are they sort of separate units of processes, or are they like device images, or like what's the granularity?
OK, good question. So in these cases, the task could be just a Unix command, and that would be executed by the default command executor inside of Mesos. But in general, it's up to the framework. So the task is just basically the task semantics are dependent completely upon the framework. So we have an example that uses just a URL as a task, and we run a web crawler. And so the executor interprets the tasks and spits back results to the scheduler. Yeah, in the back.
Can you elaborate on the rolling updates feature?
Rolling updates feature? Sure. So the main idea is that you can, in the next version, every put to an application is a deployment. And you have, as part of the app definition, a minimum health capacity. And that's a normalized value. So it could be like 0.8. That means that we'll use 20% of that room to spin up new instances. There's also a maximum health capacity that is by default 1. So if you have extra capacity in the cluster you want to use through the rolling update, you can specify that. All right. Oh, yeah.
What's the trade-off in response time you see when you use this abstraction?
What?
This application showed me fault-tolerant, and there's a lot of communication involved in the nodes. So what's the cost we give to the response time?
Response time for starting an app?
For serving a typical HTTP request.
Oh, so for applications running on top of Mesos. Okay, so the overhead is simply a C groups container. It's pretty negligible. Okay.